What's up guys, welcome to yet another video on C language series. So in this video we are going to cover about exceptions or errors that are going to occur in C language especially. So exceptions are nothing but errors that could occur due to any possible reason during runtime. So these are not syntactical mistakes, these are not caught during the compile time. So say suppose you're trying to read a file but that file doesn't exist, or say suppose you were expecting a file to be there but that file was deleted by someone else. So all of these cases are like some of the examples of exceptions. So these are the errors that occur due to runtime. So in object oriented languages like Java, C++, like we have something like try and catch. So let's take a look at a sample piece of code in Java where we are trying to create a file instance for a file that doesn't really exist. So what essentially we do is, so we predict that it's going to throw an error and we just wrap that block of code which we are not certain of that it runs for sure, like file IO or network, whatnot. So all of these are wrapped inside try and catch. So basically you will handle whatever the error occurs inside the catch block. Similarly, there's no such thing in in C language. So in order to avoid that, so we have a standard practices that people follow in C language to represent errors and also to handle errors. So generally a lot of syscalls, a lot of library functions use errno or error number, which is a standard library again, which holds the value of the error number of the previous function call or previous system call or previous library function. So without any further ado, let's take a quick example of reading a file and printing out that to std out, or like printing that out to terminal. So what I'm trying to do over here is, in this line I'm trying to get the file descriptor of the sample.java in this correct directory. Okay, say suppose this file doesn't exist, sample.java, that certainly does not exist in the current directory. So what happens is, the file descriptor or whatever basically is not going to exist. So before we conclude into any conclusions, let's quickly look at the manual page of open. Okay, so what open does is, so it takes the path name and it takes the flags and then it essentially returns a file descriptor. But what I'm interested is in the errors. So in the errors, so what they are saying is open at create will fail with the following errors. So basically I have all these errors like ebusy, efbig, einval. So all these errors, ename too long, no ent, that means the file does not exist. So all these errors are handled with one particular case, whereas the return file descriptor, the return value itself, is going to be a non-negative integer. On error, -1 is returned and errno is set to indicate the error. So this means that, so if this fails, this will certainly fail because this file doesn't exist in the current directory. So what's going to happen is the fd is going to be negative. So in order to avoid this, or do error handling in this particular case, what we're going to do is rephrase the code a little bit. So it's going to be a lot of if conditions, but like hold on with me, it's going to be fun. So what I'm going to do is, in the if condition, so in the if condition, what I'm going to do is fd equals to whatever the code I copied from the earlier. So if it is less than, or straightforward, let's put double equals to -1, that means an error has occurred, right? So let me put a comment saying that an error has occurred. Okay, so if an error has occurred, so what we are going to do is, generally the best practice is say some message on the standard error and peacefully terminate, right? So what I'm going to do is use the fprintf, and on stdr I'm going to say some kind of error has occurred while trying to read given file. Okay, and then basically it will terminate, and then let's put a line break over here. So I mean, like, there is you could also print what kind of error it is using one of the string functions. Let me just quickly bring that up. All you have to do is hash include string.h. So there is one, let me put a percentile s after the slash n, and again a slash n, and then this percentile s is going to represent str error of errno. That is what they are saying right over here, right? So they are going to say that errno is being set. So in order to use errno, we have to import errno.h, hash include errno.h. Cool, that's it. So once this is done, let me put this over here. Okay, seriously. So whatever. So basically I'm trying to print the string version of that error. So with that out of the way, what I'm going to do is return exit failure. So this is going to indicate that my program failed with some kind of error. So this is how you write defensive programming, or you handle exceptions or errors in C language. So let me also add few more code. I mean, like, I've already added few more code that is going to read the data from the given buffer and the given file descriptor from the above call. So if say suppose we don't have any error, it doesn't go inside the if, but the value of the file descriptor will be assigned, and the code proceeds and it reaches into the while loop and it takes the file descriptor and it flushes line by line data into the buffer. So over here even read could also fail. So say suppose all of a sudden you are reading and the hard disk was unmounted. So I mean, like, literally the file descriptor is open, but there is no actual device from which you are getting the data. So in such cases, of course, read is going to throw some errors. So let's see the manual page of read, and let's see, these are the errors. Again over here they are saying -1 is written on the error, and errno is set to indicate the error. Cool. So over here what I'm trying to do is, if it's greater than 0, that means the read, whatever I'm trying to read, has some number of bytes from this file descriptor. That means as long as I have more bytes to read, I'm just printing. I'm just reading that and printing it. There has to be one other condition that has to be checked. So if it's less than 0, nonetheless it's going to fail. But sometimes what will happen is, say suppose we only have like 5 characters left and you're trying to read 10 characters, or else say suppose there are no more characters left in the document, in that file descriptor cursor. So what it will return 0, but our condition says greater than 0. So we could do one thing, something like right over here I could just say n bytes or something like that, and then again similar to what we were doing, n bytes equals to whatever this read is there, and then just ignore this greater than 0 over here, and then inside the while loop all we are going to do is, if n bytes double equals to -1, that means there has been an error, and basically we're going to copy paste this block over here and the space and some kind of while reading the file, right, and it's going to print out the stringified version of that error, and then it is going to peacefully exit with the exit failure status, right? If that doesn't happen, it is going to successfully print. So this is how you write defensive code in C language, or in simple words you could call this is how exception handling works in C language. That's it for this video, guys. And also let me quickly run this video for you. You might be thinking this guy wrote all this crazy code and he doesn't even compile it. So okay, so we don't have a read. Read is in hash include unit standard h. cool it compiled, and if I see, no such file or directory, right? Because sample.java does not exist. If I remove this and then if I do this, oh, I did not recompile, sorry, my bad. As you can see, it's printing the contents of the Java file. So this is what we expect. So that's it for this video, guys. See you again in yet another C language video, or maybe this time I'm going to see you in some Linux distribution that I'm going to check out and leave a review on it. Peace.